Hey guys, today we are going to discuss the topic of identification of gases. Identification of gases. It means that how we can identify a gas. What are the tests for identification of a gas? We have to find out what is a test and we have to say this thing as well, that what will be our observation in that test as well. Okay. So now, for example, there is a gas number one, which is called as carbon dioxide. Carbon dioxide. Okay. Now, what is the test? So, first of all, sometimes examiner is writing test separately and observation separately. Sometimes he is not writing these two things separately, and he's just saying describe a test for the identification of that gas. Over there, you people should merge the two things. I mean to say the test and the observation. Okay. Now I am telling you. Okay. So, what is the test for carbon dioxide? Pass the gas pass the gas through lime water. What is the formula of lime water? CaOH twice. Do we need to memorize the formula of lime water as well? Yes. Pass the gas through lime water. Okay. And what is the observation? All right. What is the observation for this? It is gas will turn lime water milky. Gas will turn lime water milky. So this is our observation. Okay, what is the test? Pass the gas through lime water. And what is the observation? The gas will turn lime water milky. Is that clear right now? So this is how we are going to write the test for carbon dioxide. I'm going to change the board so that you people may be aware with the next type of the gases and their test. Okay, test number 2 is related to, I'm changing, okay, related to ammonia. This is ammonia. I'm writing the name ammonia. Okay. Now, what is the test for ammonia? It is a test here, first of all. Bring HCl rod near the mouth of near the mouth of test tube containing ammonia. What is the observation? White colored white colored cloud of NH4Cl, ammonium chloride, ammonium chloride will be observed. There is another test for ammonia as well, and what is that? Immerse, or you may say pass the gas over damp red litmus paper. And what is the observation? Being alkaline gas. Is it important to write being alkaline? It will give you it will give a better impression of your paper. So being alkaline gas, ammonia will turn red litmus paper blue. Is that okay? So this is the test for identification of ammonia. Okay, so there are two tests. Do I need to write both of the tests in the paper? No, you people can write one of the test in the paper. Is that okay right now? So this is how we can write the test for ammonia. There is another gas, that is gas number 3 here, and that is called sulfur dioxide. Okay, sulfur sulfur dioxide. Guys, I'm telling you one information before time. I'm really very sorry for that, but I will definitely explain these terms in detail when I will teach you that chapter, inshallah. Right now, this is sulfur dioxide. And what is the term which I'm telling you? It is a reducing agent. Reducing agent. At this stage, I am not willing to explain this term of reducing agent to you people because this is quite before time. But I would like to request you people to keep this term of reducing agent in your mind. Okay, so this is how it is acting, and what is the test for that? Okay, so it is a test first of all, and the test is pass the gas through acidified K2Cr2O7 or acidified KMNO4. Full stop. That's it. Okay. Let me tell you some things in detail. Okay. What is that? KMNO4 is called potassium manganate. Do I need to memorize these formulas? Yes. Potassium manganate, and this is K2Cr2O7. This is called as potassium dichromate. Guys, let me tell you one more thing, that both are oxidizing agents. Both are oxidizing agents. Okay, so what is the nature of sulfur dioxide? It is a reducing agent, whereas what is the nature of K2Cr2O7 or KMNO4? Both of them are oxidizing agents. Okay, so there is a reaction between both of these. That what is the reaction between both of these? I'm going to share that reaction with you on the next page. Okay, so what is that, G? Pass the gas. Instead of writing that, I would like to make a sketch of that. Look at here, guys. This is sulfur dioxide. We have passed it through acidified. Acidified, either HCl or HNO3 is added to make it acidified. What is the meaning of the term acidified? Means it is acidic in nature. Okay. Pass it through K2Cr2O7. Okay. And what is the color change? It will change the color of K2Cr2O7 from orange to green. So what is the original color of K2Cr2O7? It is orange. And if it is turning its color from orange to green, it means that there is some reducing agent which has changed the color of this oxidizing agent. Okay. So this story is very, very simple and clear. that K2Cr2O7 is an oxidizing agent. If something is changing the color of K2Cr2O7, it means that something is reducing agent. That something is reducing agent in its nature. Okay, so this thing must be clear in your mind. This is really very important regarding a paper point of view. Okay, so sulfur dioxide gas is passed through K2Cr2O7 and it is changing the color of K2Cr2O7 from orange to green. Okay, there is another, and that is SO2 is passed through KMNO4. Again, I'm writing acidified KMNO4. Okay, and what is the color change? The color change is from purple to colorless. So what is the color change in case of sulfur dioxide? It is changing the color from purple to colorless. And what is the color change in case of K2Cr2O7? It is changing the color from orange to green. Is that clear right now? So these are the two color changes which are associated with sulfur dioxide. Done, guys? So this is how we are going to deal with sulfur dioxide. This is the test number 3. Okay, and now I'm taking you to the next page, and that is a page number 4 related to gas number 4, you may say. Okay, and what is that gas? It is called hydrogen. Okay, and what is the test? Bring the lighted splendor. Bring lighted splinter lighted splinter near the test tube having hydrogen gas. Okay, and what is the test observation? Gas will pop in the flame. What is the observation for hydrogen gas? It will pop in the flame. Is that clear right now? So what is the test? It is to bring the lighted splinter near the test tube. So for example, if we are performing any chemical reaction and the gas which is producing, I'm going to draw that as well for you people. You can see this is, for example, a test tube. Okay, and there is a reaction between, you may say, zinc plus HCl are reacting with each other. As a result, ZnCl2 is forming, along with that hydrogen gas is forming. Here is a hydrogen gas. Okay, so guys, I'm going to draw the bubbles of the hydrogen gas here. Okay, so these are the bubbles of the hydrogen gas, for example. Okay, and there is a gas. Okay, so what we are going to do, we are going to keep that burning splinter here. This is the burning splinter here. This is the lighted splinter or burning splinter here on the mouth of the test tube. Now what will happen? As a result of this test, what will happen? There will be a pop will be observed. Okay, so guys, you people are not allowed to say pop sound or pop this or pop that. So what you have to say it here, it will pop in the flame. Is that clear right now? It will pop in the flame. Done. So this is how we are going to write the test for hydrogen. Okay, now there is a final test on the next page, and it is the gas number 5. And what is that gas? It is called as oxygen. Oxygen gas. Okay, so oxygen gas can be identified by a specific test as well. And what is the test for that gas? Oxygen, and it is the test here. Bring the lighted splinter near the gas. And what is the observation? Oxygen will reglow the lighted splinter lighted splinter Oxygen will reglow the lighted splinter. Okay, that's it. Okay. So, for example, if the flame was of a very smaller size and you are bringing that flame near the test tube in which a chemical reaction is happening, and as a result of that chemical reaction, oxygen gas is going to be produced. Now, what is happening? That oxygen gas is going to increase the size of that lighted splinter. It is going to increase the size of that burning splinter. So this is how a chemical reaction can be used to identify the gas oxygen. Okay. So there is a test for oxygen and hydrogen, sulfur dioxide and ammonia and carbon dioxide. Guys, there is one more test, and that is for chlorine gas. This is the last test. Okay. And this is for chlorine. Okay. Here I'm writing chlorine, formula Cl2. Do we need to memorize the formula? In every video, I'm going to tell it to you, and I'm telling it to you that it is very important to keep the formulas in your mind. Okay, so this is chlorine, and what it is, a gas. How we can identify? There is a test for this. Okay, what is the test? Pass the gas over damp blue litmus paper. Guys, let me tell you one thing very clearly, that chlorine is an acidic gas as well as it is a bleaching agent. Guys, chlorine is the same bleaching agent which is used in our homes to bleach the clothes, okay? And chlorine is the same bleaching agent which is used in the swimming pools as well. All of you must have observed that there is a pinching smell in the swimming pools. Some of you might have some allergy from that chlorine in their eyes or the skin. Might be you have observed that after swimming, your eyes are getting red. And why it is so? Because of the chlorine which is added to the swimming pools. And what is the reason why chlorine is added to water and why chlorine is added to the swimming pools? Because it is a disinfectant. It is used to kill the germs and bacteria. You may say to kill the microbes. When I will teach you the chapter of water, when the topic which is under the category of air and atmosphere, over there is one treatment which we are going to water. And what is that treatment? We are going to kill the microbes in water, and how we can kill that microbes in water? By passing chlorine through that. Okay, so chlorine is a bleaching agent. It is used as a disinfectant to kill the germs and bacteria in water, and it is an acidic gas as well. So these all points must be clearly fitted in your mind. Okay, now I am taking you to the next page, and what is happening, okay, we can do it on the same page. And what is happening, we are going to identify chlorine. Okay, so what is the test? It is pass the gas over damp blue litmus paper. And what is the observation? Being acidic in nature, it will change the color of blue litmus paper to red, and being a bleaching agent, it will change the color to white. So remember this thing, guys. This is very, very important. Let me tell you on the next page. Okay, so this is chlorine, and this is blue litmus paper. It will change it to red, and then red to white. Okay, and here it is the chlorine, and it is on the red litmus paper. This is an answer to one of the past paper question. And this red litmus paper will be turned to white. So what is the question? Which gas is changing the color of both red and blue litmus paper? This is chlorine, which is changing the color of both red and blue litmus papers. Why it is so? Why it is changing the color of the blue litmus paper? Because it is an acidic gas. And why it is changing the color of the red litmus paper? Because it is acidic in nature. Hydrogen is a gas which is not changing the color of any litmus paper. Oxygen is a gas which is not changing the color of any litmus paper. So, what is the key idea? That all neutral gases are not changing the color of any litmus paper, but all acidic gases are changing the color of their blue litmus paper to red. And basic gas, which is ammonia, only it is changing the color of red litmus paper to blue. And this is only chlorine which is changing the color of both litmus paper, and it is changing the color to white. And why it is so? Because it is a bleaching agent. Is that clear to all of you guys? Thank you very much to all of you. In the next lecture, I'm going to tell you identification test for water. Okay, that is also very important regarding paper point of view. Thank you very much. Take care.